Hi, and thanks for your email. I've got your questions. There were 3 of them in that email, so I've got them each on a separate page for this video in the program that I'm using. So let me start by explaining what the number 41 means, okay? We have a function here, h of t. Oops, that should be an equals there, sorry. And what I'm going to do is, instead of writing the square root of 1 plus t squared over 1, I'm going to write it as the square root of t, like that. So if I started like that and I wanted to do a substitution into that formula, then I might say substitute in find h at 4 or something like that. All that would mean is that I have to replace the t with 4 and work it out, and so I could get an answer like 4 there. In this question, what they're doing is not just substituting a constant in, they're substituting another function in. So they're giving you a second function, g of t, and they're saying that that was substituted into h of t, and that the result was this, okay? And so if that's true, they're asking you to come up with a function, an original function that they call f of t, that would look like that. And so if we substitute for t the 1 over t squared plus 1, then we have h of t, which is the composite function where we've put g of t in place there. And so that's what they were asking you to find, was what would the original function have looked like before we substituted that g of t, which is 1 over t squared plus 1, into it. And so you just have to kind of work backwards and decide what it would have looked like. So for part B, if g of t is t squared, and we need to find a function f so that h is f of g, then the only thing that we can substitute in is the t squared this time, and we want it to end up looking like this. So we have to think about what was t originally, where was t, so that if we replace t with a t squared, we end up with this equation. And so for part B, we have to consider that f of t looked like this, because the only change we want to make is we want to substitute in g of t equals t squared. And so in other words, we want to replace that t with t squared, and we want to make it look like the original function here, h of t. And so if g was equal to t squared, that would do it, and that would give us the composite function, h of t equals 2 plus 1 over t squared plus 1. So I hope that makes a little bit of sense. It's a little tricky, but once you start working with them, you see the patterns over and over. So I would recommend just practice these if you can find some more in your textbook with answers available, and just practice them or do these same questions over 2 or 3 times just to really see the shortcuts and what's going on there. So here's the second question that you asked me about. It's the same idea as the first one, only in this case they've got 3 functions all being substituted in. So you start with the original function, you substitute one function in, and then you substitute another function in for that. So it's just a little bit of a test to see that you understand the idea of substituting one function into another. So again, this is our end result that we're hoping for, this t of x equals 4 over 5 plus x squared. And they're saying to just find any other functions that we always kind of work backwards. We substitute g into this, we substitute we substitute h into g, we substitute g into f. And so if we work backwards, and we've got the answer provided, which is really helpful here, because you can kind of see that if you start with 4 over x, that one of the first things we could do is we could switch that to 4 over 5 plus x by just letting g of x equal 5 plus x. And so this would be f of x, and this would be f of g of x. So we've substituted the g part instead of the x. Now we have 5 plus x. And if we have to do one more substitution, then that's going to be f of g of h of x, and we're going to have 4 over, and we had 5 plus x, but we're going to switch the x now for an x squared. So everywhere there's an x, we would substitute x squared. So that's a composite function that's actually the result of two different substitutions, because we started with the original simple function, then we switched the denominator, we took the x and we substituted 5 plus x, and then we took that denominator and changed it again by taking the x and substituting x squared. And so it's just a progressive change towards the final answer. Now here's the third question that you sent me. Okay, again with this one, having the answer provided is really helpful. And it again is sort of a work backwards thing, okay? So the thing that we need to understand is when we see this kind of notation, we pronounce that as h of f, but what it really means is it's evaluating h at a value of f. So normally we're used to seeing that as like f of 3 or h of 4 or something like that. And that's telling us to take those values, 3 and 4, and substitute them in for x in the original equation. It gets a little more confusing when we're doing composite functions because we're not just putting in regular values like 3 and 4, we're putting in another function. And so all they're saying here is that we're going to start with an original function like this one, 3x minus 2, and we're going to substitute another function into it. So where would it go? And what they're asking you to tell them is it would go right here in place of the x. So whatever that function is, if we're going to substitute function f of x in to the first function, then it would go right here. So whatever it is, we would stick it right there. And we don't know what it is. Like maybe f of x is x squared. So that would mean that I would be substituting x squared in place of x, and I would end up with that for the answer. Until they tell us what the function is, we don't know. So we're just going to hold the place of it like they have with 3 times f of x. So whatever that function f of x happens to be when we find out, that's what we will replace x with in the original equation.